This is my report for the glider project. The name of my glider is Venus. The goal of this project was to build a glider from balsa wood and other simple household materials. It was a very open-ended project with rough guidelines, which allowed a lot of freedom. I had to make many design decisions involving shape, weight, materials, and construction. This report documents all those decisions and the final results. Here's the design process. To start, here are the requirements. The requirements are listed on the left, and on the right it shows the measures of success for each of those requirements. When doing research for my glider, I had to make decisions about different aspects of the glider. One of them was about the wing shape. I had to decide between a rectangular, a swept back, or an elliptical wing. Here are the pros and cons of each of those. Here are pictures of a rectangular, swept back, and elliptical wing. For the tail, I also had to choose what tail to make. So I chose between a T-shaped, flat rectangular, or a V-shaped tail. And here's the pros and cons of each of those. And here are pictures of a T-shaped, a V-shaped, and a flat rectangular tail. I also had to choose what material to use for additions and for my first iteration. My options were balsa wood, cardboard, and foam, and here's the pros and cons of each of those. In the end, my choice for my first iteration was to do a rectangular wing, a T-shaped tail, and cardboard. I chose this based on my goals for my first iteration, which were for it to be simple, easily modifiable, and to have really high lift and low drag. I wanted to be able to make quick modifications and mini tests to determine the best alternatives for my final glider. For the sizing of my initial glider, I wanted it to be very simple measurements that would make construction really easy. I also made the glider smaller than it could be to conserve materials so I could easily recover from a mistake and start over. The sizing was done mostly by intuition because I'm familiar with the relative sizes of pieces of an airplane or a glider. And I used about 75% of my materials in this design, so I had a little left over in case I needed to make small additions. The first iteration of my glider was made using part of the provided fuselage and cardboard. I chose cardboard because it would make it easy to make adjustments, and I chose a rectangular wing and a T-tail. I chose a rectangular wing because it was the simplest and most reliable and didn't require any fancy manufacturing stuff, and I chose a T-tail because it provided the most lift, and that was one of my goals. Here's a picture of iteration 1 with my cardboard wing and tail, and you can see it's a rectangular wing and a T-tail. After the initial testing of this initial glider, I found it was not good. My glider was not stable. The center of mass was far behind the wing when it should be right under it, but also my glider was nosediving. So adding mass to the front of the glider that helped stabilize it just made a nosedive even worse. So also, as you can see from my initial performance, here's the list of distances of test flights. My glider was not even making the goal of 20 feet. So it was very unstable and not reaching the goal. So after many iterations trying different wings, different tails, different materials, I came to my final glider, and these were the 4 things I improved. First, I improved the wings. So I decided to sweep back my wings slightly and place them farther back on the fuselage. I swept them back to reduce drag from the front corners, and I moved them so that the center of mass would be right under them, making the glider naturally stable. The tail was my biggest problem with my first iteration, so I completely changed it. I changed it to just a flat rectangular tail with a stabilizing vertical piece in the center. Now, for the weight or the materials, I replaced the cardboard from the first iteration with balsa wood, and this greatly improved my glider's performance. The glider was just too heavy and bulky, and the balsa wood is lighter and thinner, so it's more aerodynamic. And also for the velocity of me throwing the glider, after multiple tests, I discovered that one of the reasons my glider was failing was because I wasn't throwing it with enough initial velocity. So for the final glider, I focused on throwing it harder so that it had enough velocity to actually generate lift. So here's a picture of the final design. This is Venus, my final glider, and she has swept forward wings, a simple flat rectangular tail with a vertical stabilizer and mass added to the front, and she's made of completely balsa wood and then a little Play-Doh with the mass at the front. So the center of gravity on Venus is right here. It's just a little bit behind the quarter cord, and in this picture, the front of the glider is to the right, and this makes her very stable because the center of mass is under the wings. So here's my estimation of the coefficient of lift and coefficient of drag. Here's the formulas and the inputs for both of these. So this is how the design iterations impacted the final performance. For the location of the wings, I think that placing the wings in a way where the center of gravity was naturally right under them and not having to add mass to the front to make the center of gravity right under them really helped my glider. It made my glider very stable and balanced, and it was easy to make the 20-foot goal this way. For the tail, using a simple tail design, one that's used most commonly in commercial aircraft, was a really good design choice because it was really simple to build and provided just the right amount of lift to keep the glider in the air, which is different from the T-tail, which provided way too much lift. And then for the materials, for the final design, switching to using the balsa wood over the cardboard greatly impacted my glider's performance. The iterations made of cardboard consistently failed because the cardboard was just too heavy and bulky, and the balsa wood is very lightweight and thin, so it's more aerodynamic, and it makes it better for the glider. Here's a video of my best flight. It went 30 feet and had a velocity of 15 feet per second. For the final design, yes, it met all the requirements. And here's a list of requirements again. The most difficult was reaching 20 feet, but my glider did make it. So to conclude, first we talked about the research I did and how I decided between different alternatives for the wing and the tail and the materials for my first iteration. And then we talked about my first iteration and the testing I did on it and how I found it really wasn't stable and was not reaching the goal. And then I went through multiple iterations of just trying different wings, different tails, testing things before I finally came to my final iteration with the swept back wings and the flat rectangular tail and using balsa wood instead of cardboard and throwing it a little harder. And then we had my final flight, which was successful. So in the end, this project was really hard. I came in with minimal prior knowledge and had to learn a lot, and it took many tries for my glider to be successful, but in the end, it just barely made it. So one thing that I did learn is that I can't be afraid to ask for help and rely on others who do know a lot more than I do. So for some further improvements, I could make the added mass permanent, sanding down some rough edges, adding vertical tips to the wings for stability, using a lighter weight, thinner fuselage, or throwing my glider at a straighter, faster, and at a perfect angle. Those would all make my glider better. And here's my references. Thank you.